It's live. I never know how long it takes after pushing the button before it actually goes live. And of course, we're doing this via Zoom. So first of all, welcome, Stefan.
Thank you.
Excellent. Everything's working. We did get on tech check this earlier on. I don't think I've done something on Zoom live stream since COVID time for Scott. It was pretty wild. It's a long time ago. All right, so we are going to be doing a bunch of like have I been playing architecture stuff in terms of the blog post I wrote yesterday, which I'll run through soon. And then I'll just keep throwing interesting stuff to Stefan to embellish on further. Then I thought we'd get Stefan to talk about more of what's happening on the back end with the database as well, yet to be blogged.
Mhm.
You can do the preview. And then some of the feedback we've had too. One of the things I find annoying when you do use Zoom to broadcast, as far as I know, when there's two of us, it only shows the person who's talking. So if you're joining this and it just looks like me, it's not.
All right. So if I say something, I should pop in then.
Yeah. And then the live stream
Ah,
that we see
there
is
it is.
slightly delayed. Okay. Yeah, but you're there. So anyway, so it works, which is the important thing. Let me just do some sponsorship stuff first, and then we'll jump into everything else. Sponsor this week feels very repetitive, which is good, is 1Password. Eventually we'll get everyone using password managers and everything will be fine. We'll be out of a job. In this case, 1Password, Extended Access Manager, or XAMPP, securing every device, every app, secure every sign-in for every app on just everything. It's still early here. It's 6 a.m. So for those folks who have not seen the backstory on this is what came from the Collide acquisition. And I think this is interesting because it's not just the password manager bits of the password manager. And every time someone says to me, it's like, well, isn't it just a password manager? Well, it kind of was, but it's very different now. And it's very different to just using the one built into iOS, for example. You're a 1Password guy, aren't you, Steph?
Yeah, yeah.
Yeah.
Love it. Actually, like pretty much turned my entire family on it. We're trying to. It's a bit of
Mm.
a hurdle to get non-techies to use it, but it's getting there.
It's I think that's one of the neat things about it, like the family integration. So we share so much stuff via our 1Password with the kids. Like Charlotte and I both have our own private vaults, and then we've got a shared vault between her and I, and then we've got a shared vault with one kid and a shared vault with the other kid, and then everything sort of goes into there. And now it's really cool seeing when one of the kids has to set up an account for yet another thing because they're a human on the internet, so then it accounts for everything. And yeah, they just fly in there and create accounts, like strong passwords, and it's good. It's good. Uh, hey, before I jump into this, so I want to hit you with something interesting because I was just arguing with people on Twitter. There are still people on Twitter, they still argue. I thought I'll ask you this question. We haven't discussed this in advance, but let me find the tweet. I don't know if you saw me post this just before I went to bed last night, which is always a bad idea to post something controversial just before then because you wake up with, yeah. Our Prime Minister has introduced a bill to make 16 years the minimum age for social media. And this has been in our press here for a little while. And now the government has said 16. So you've got to be 16. When the bill passes, there'll be 1 year to go. So we're still talking about probably later next year. But say our daughter, Elle, who's 12, would not be able to get social media for, well, she'll be able to get it when she turns 13, but then some months later, when the bill passes, or rather comes into effect, she won't be able to use it. What do you think about this? You've got kids. What's your view?
Uh, so I understand the idea, but I don't really see how you're gonna implement this. I mean, yeah, I mean, like, are you gonna ask every social media app to put like a, hey, if you're from Australia, then you gotta like send us a picture of your passport before you can log in, please.
Yeah.
And if you don't, then like, or if you actually do get in without having to, then like, what are they gonna do then? Like, I don't see how you're gonna be able to enforce this really.
How old are your kids now?
11 and 13.
Okay. And does the 13-year-old have social?
Yeah, some, but like with restrictions.
And I mean,
Yeah.
for our son Ari, who you know, our kids, we on his 13th birthday, it's like, I'm going to set you up with all the things and we're going to do it right. And there's going to be multi-factor and strong passwords and the whole lot. And that's been fine. I think I'm trying to think back. I think it's more about the addiction that kids get. And I'm kind of with you where like, how are you actually going to do this? Because the problem is, isn't it? You can't just do it for kids. You have to do it for everyone in order to prove that you are 16 or more. And then you've got so many people who don't have a passport, so many people who don't have a driver's license. And I think if it ends up just being like when we go to a beer website, it's like, are you 18? Yes. Okay, cool, go. Well, it doesn't work. You know, a lot of people are very upset when I shared this because I actually like the idea of keeping kids off social media for longer, but only if you can do it consistently across, let's say, everyone in the school class. Because if you can't, then you get so much pressure because yeah, Jimmy and Joey got social media and all the other kids have it, but I don't have it. And then you, as the parent, are the ones who have to make the decision. And I don't think our government has kind of thought through how they're actually going to tackle that. Like you literally have to have controls in place to make it unavailable to the under 16s because you can't just go, well, parents don't give it to your kids because they do.
Yeah, I mean it's a I find it's pretty much the same with all these social media apps and kids as well. And like you said, it's also the same thing with like video games. I mean you can put all sorts of like screen time restriction and everything else, but if the kids get bored, they just go over to the friends and play at their house instead. Like
Yeah.
it it I think the only like way to really tackle this or like tackle it, not tackle per se, but it's like you basically just have to try to educate your kids. And it has to be like a parenting. I can't really see how the government's going to step in there and say like, no, kids can't do this much. Like it's more of a parental thing, I think.
Yeah, and I've just seen Nick 007 say here as well, you know, how are they going to enforce it? And I think it's almost like two parallel issues. One is like, would it be a good idea to keep kids off social until they get to 16? You know, have that discussion. And then the other one is, how do you actually implement that? And I mean, we've seen attempts to put like controls on access to porn and so on in different parts of the world and having to show your identity beforehand, but then you run into the privacy problem. It's like, well, if you maybe the porn's a different example, but even in that case, it's like if people are going to watch that sort of content and they're legal consenting adults, how do they do that without having their browsing habits tied directly to their IRL identity? And that's the same problem here. It's like, look, if kids do want to use social and maybe they want to use it under a pseudonym or under another identity, if they have to have an identity proof before they get that, I think it's just, I think there are more problems than what is going to be feasibly solved.
Yeah, I agree with that. I think it's yeah, I think it's like it makes like the idea makes sense, but I can't really see how you're going to implement it efficiently or in a way that works.
I feel it will be a little bit like the way we see some responses to things like E2E encryption, where the government says, um, we need to be able to see what's in here, or we need to be able to see the communication. You guys figure it out. That's like, okay, well, where have we landed with? Well, actually, where we've landed with that is that E2E still does exactly what it does, and you then have to figure out ways to access endpoints, which is probably a good result. E2E still works.
But wasn't Australia going to ban math as well? Weren't they trying to like ban encryption the
Oh,
other day?
I can't remember if you've seen it, and I know I put in a talk once, but we had a former prime minister who was asked about the fact that encryption is just maths. And if you want to ban E2E, like how are you going to ban maths? And our prime minister's response was literally the laws of mathematics are admirable, but the only laws that matter in Australia is the law of Australia. It's far out.
Yeah.
Anyway, he's gone now. He's like several prime ministers ago. Let's talk about something less controversial. Let's go and talk about what we've built here. So, it's I just realized it's about 2 weeks away until it's the 11th birthday of Have I Been Pwned, and over that time, initially me and now you and I together have been trying to figure out how to support it as it gets really large with 14 plus billion breached records, make it make it go fast, make it cost effective enough to run, particularly at scale, and sort of jumble all that stuff up together. And then over the course of time, as new technologies and things have become available, serverless, for example, via functions in Azure, more recently, serverless SQL as well, which we've rolled over to. I'm sure we'll talk more about SQL too. And then, of course, all the Cloudflare bits and pieces. And we've seen, I think I put Have I Been Pwned behind Cloudflare. It must have been about 7 or 8 years ago now, because it was the only way I could get on top of really abusive patterns towards APIs. But then of course we've had workers come along, we've had R2 storage, we've had cache reserve, we've had all these different ways of doing cool things on the edge. And I think what we've done here is mostly really, really cool. And I think we should talk about some of the bits where it's not. But just to do the full recap, so for people who haven't read the blog post, or if you're listening in the car, let's have a bit of a run through about the mechanics of this. So at the moment, every time someone goes to Have I Been Pwned or troyhunt.com, or your blog must be behind Cloudflare as well, right?
Yep.
Yep. Okay, cool.
Yes.
Well, I mean, a significant portion of the entire internet is behind Cloudflare. Every time you go to one of those resources, you're hitting an edge node close to you wherever you are in the world. So there's, I think, 330 edge nodes was the quote I've got in here. So for me, I'm going up the road to Brisbane, which is about 80 kilometers away. I connect there, and then Cloudflare can decide where the traffic should go. And at this point, a bunch of people get really upset because they're like, Cloudflare is literally man in the middling your traffic. It's like, yeah, well, that's the value proposition. That's a feature that works well. And then they can decide whether they block it, whether they send it to the origin or serve it from cache. And the discussion you and I started having, I feel like this was probably about 6 months ago, was what if we could start to just put everything in cache? So all of the breached records, just put them in cache, because if we could start to serve that from edge nodes instead of the origin, we'd get a bunch of really, really cool benefits. So the obvious one is we'd get a much faster response time. Now, I literally went into like Google and checked all this. It's about 80 kilometers for me to go to Brisbane and about 12,000 kilometers to then go from Brisbane to the West US data center, which is where our origin services are. So obviously, if I can serve something from 80 kilometers away, it's going to be significantly faster than 12,000. So that the speed is really important. And as you've seen, as soon as we have any sort of drop in speed and increased latency, we hear about it really quickly. Like we've got a few subscribers in particular that hit it pretty aggressively. Now we also, just to be clear, like we know who these subscribers are. We know who all these subscribers are because they've got to put up a credit card or sign an agreement first. And they're things like identity theft protection companies using it in the way we want it to be used. But if they see latency increased by 50 milliseconds or 100 milliseconds, like we'll hear about it. So we're trying to make that faster. The other thing is, I think when was the last time there was actually an outage in Azure? You remember?
No, can't really remember. I think it actually happens. It happens more rarely than actually we break stuff. So
yeah, we break stuff more than Microsoft breaks stuff, which you'd kind of hope for, really. It's like we're just two people winging it. Microsoft has greater resources. Anyway, the point is, I think the availability of the underlying services has actually been really good, but yeah, occasionally there have been in the past outages at Azure. Occasionally we have broken things at Origin. If we can avoid having to go to Origin, we take out variables which can lead to downtime. So our availability is better when you only have to go like this far instead of that far and then hit all those other things that run over there. And then the other thing is the cost. And man, cost management is hard. And if you get it wrong, it can hurt really, really fast with cloud. Like, remember a couple of years ago when I suddenly got hit with all that egress bandwidth and got like a $12,000 bill or something. Yeah, just from bandwidth. And bandwidth,
yeah.
I think egress bandwidth from Azure is probably one of the costs that surprise people the most. Like it's really, really expensive. that stings, like that and the SQL database. It stings. But and yeah, you'll talk more about the SQL stuff later on. But the pain that we have with SQL is that SQL serverless, I just don't like that term for the way this SQL's done, but let's just humor them and say it's serverless for the moment. We've got to still have a certain number of cores, and the more cores you have, the more money you pay. And even if your data is the same, and there is a cost for data storage, and then a cost for backup, and then a cost for long-term retention. But if we need 20 cores instead of 10 cores, we're literally going to pay twice the amount of money. So if we can keep that traffic off the origin and off needing to spin up more cores, we save money. And it's like win, 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 win. Like people get stuff faster, we get better availability, and our cost goes down. So we started sort of going, well, how do we get 14 billion records and store them at Cloudflare? And one of the things we realized is that it's not quite as bad as 14 billion, because there are really kind of two different ways of querying this data. So one is by your email address, and that happens on the front page of the website, and that happens with the public API that you can sign up for via Stripe, chuck your credit card in. And the other is the k-anonymity model, which is effectively the same model we use for pwn passwords, except we get an email address, we get a SHA-1 hash of it, and then you search by the first 6 characters of the SHA-1 hash. And this is something we make available just to a small number of enterprise subscribers like 1Password and Mozilla Firefox Monitor. And I'm surprised I haven't been asked this, but the reason we only make that available for enterprise level customers who have to sign very lengthy agreements is that if you search for a hash prefix, so let's say you search for 6 A's, just to make it simple, you're going to get back every single hash suffix that finishes after the 6 A's. So we've then got another 34 characters worth of data. How many results are we returning per hash suffix? It's like 300 or something, isn't it? Per hash prefix.
Yeah, I think it's about 300.
So effectively, one query returns about 300 results. And now suddenly the control around limiting how much data can be queried for many good reasons fundamentally inverts, because now one query is returning several hundred results. So anyway, we just make it available to those style of customer. But what it means is, because there's only 6 possible, or because there's 6 characters, and of course each character has got 16 possibilities because it's hexadecimal, we've got 16 to the power of 6 different possible queries, which covers our entire database. So we went, well, that's a finite number. That's about, I think it's about 16.1 million. What if we just start caching those? So that's what we've done. Like when you search, have I been pwned? If you're searching using one of those enterprise APIs and you search for the 6 A's, well, then we go, okay, is the 6 A's in cache? No. Okay, go to origin, bring it back, put it in cache, return the result. If you search for an email address, then we can, in the Cloudflare worker, so Cloudflare workers being code on the edge, we can SHA-1 hash that, take the first 6 characters. Is it in cache? No. Okay, go to origin. So what it means is we can gradually build up this collection of up to 16 to the power of 6 different possible cached items in Cloudflare. And by turning on Cloudflare Cache Reserve, which is a little checkbox, it stores it in R2, so there's no cache eviction, which means that if we run the whole thing for a month without evicting anything from cache, we'll probably get every single possible hash range in there. So how's that so far? Have I missed anything?
No, I think you're pretty much spot on so far.
We have been kind of living and breathing this for quite a while now. So anyway, we build up this big collection of data in cache until we have to load a data breach. And this is the bit that's a bit painful, because if we load a data breach, let's say that one yesterday was 900,000 records. Now the 900,000 email addresses, that won't necessarily be 900,000 unique hash prefixes, because we might find that there were 2 different email addresses in there that hash down to a SHA-1 value that begin with the same first 6 characters. So maybe it was like 870,000 unique hashes. I don't know. There'll be some, I'll rephrase it, 870,000 unique hash prefixes. as far as I know, we've never had a hash collision. That's an interesting idea, isn't it? Even for Pwn passwords, I don't think we've ever had a hash collision because something would get upset somewhere, wouldn't it? Or a hash collision would just simply mean with Pwn passwords, we've effectively got a false positive. Huh.
Yeah, I mean I mean I don't exactly have the math in my head, but like if you have like with a SHA-1 hash, like just with the like you have 20 bytes of entropy in there. I mean the likelihood of a
Mm.
hash collision is going to be very, very small.
Well, you've got 16 to the power of 40 different possible SHA-1 values. I don't know
Yeah.
what that number is. I just know it's got a lot of commas. So that's a massive number. Uh, and then what would happen if we did have a collision? You'd just get a false positive on an email address search, which is, this is not like, it's not like using SHA-1 for integrity checks. And what would happen if you had a collision? Well, someone gets to fraudulently submit a document and take all your money, or, like it's not that. So, when we load a breach like that one yesterday, we got 900,000 email addresses. Regardless of how big the breach is, we just have to flush the cache. And the painful bit is it's almost like we built up this beautiful distributed global cache to 330 edge nodes. And then it's like, new data breach, like wipe it all and go from scratch. And then we have to start building everything up again. And based on the blog post yesterday, I think it's taking us about 20 hours to get to about 50% cache population. And then the rest of it's a very, very long tail. I guess that there's a couple of problems that creates, a couple of necessary problems. So one is that we lose all of that ability that we built up to serve stuff locally. So we don't get to just return it from somewhere geographically close to you. We have to return it from the origin. We have to obviously then pay for all the egress bandwidth and function executions and SQL Server cores and things that we just managed to get away from. The other problem that creates for us, and this is very evident when you look at the graphs and the request to the origin server, is that in the example I've got here, it's like we got down to just about no requests going to the origin. And then suddenly in an instant, 30xing the traffic because now all the cache is flushed and every single request goes through the origin. So our challenge is that we need to have origin services that can handle a sudden and ginormous increase in traffic, which the functions really do. So functions remain our app tier and they're serverless and they scale, but the database is where we have a bit more trouble with. Let me take a break and you can talk about what are we actually doing with this database in order to service traffic like that.
So, well, when we actually like decided to migrate off table storage, uh, we actually like we sat down and we spent a good amount of time just like designing the tables, how we're gonna put up the tables, how we're gonna do the indexes and everything else. Because with the amount of data that you have, like I said, like 14 billion records, as soon as you like put one column too many into an index or like starting to indexing the wrong thing, if we're talking like gigabytes of indexes, like well not just gigabytes, to hundreds of gigabytes actually. So we spent a good amount of time on like designing the table so it would be so we would be able to like insert data into it and it just not taking forever, for example, and then being able to query it at pretty much the same speed as we were querying it from table storage because we couldn't really afford to like slow things down either. Like that would kind of break the point of the migration, of course. Like one of the big reasons was to get reliable backups as well, because table storage doesn't have those. So once we had actually like migrated all the data, then we ran both of them side by side for a time. Um, so when you were like importing data breaches, we were putting them both into table storage as well as SQL. And then we started to like take like I said, like our app tier, which is the Azure functions. We started to take them one at a time, pretty much we would move one function over to doing like SQL queries, and basically try to take it step by step to get a sense for the load this was going to cause in the database. Because like even like you said, because even if we have a database that's supposed to be serverless, it doesn't scale forever, and it's really apparent when we're using that database that it scales a lot more slowly than the functions. Like functions are really, really quick to scale up when we need, but scaling the database takes minutes. And scaling it down as well. So it was a tricky problem to solve. But we got good help from both from Microsoft and some other MVPs as well, and getting that into a good place. And then we started, like I said, we started also talking about not just being able to move the data over to the database and make it fast. We also had to have like a proper cache in front of it. So that's where when we started moving stuff over to the Cloudflare workers as well. And then we actually really started to see the benefits of the caching, because we'd always done this with Pwn passwords pretty much. We sort of had the base recipe for this, how we're going to do this. But this still required us to do some other things. For example, like you have customers which have API keys, so we had to validate them as well. It's not a completely anonymous API like Pwn passwords is. So there were a lot of moving parts in there. Like even if we had like the basic idea and it was simple enough, then we had to be able to make this work. And then, like you said, we couldn't afford either. For example, while you're loading a data breach, we can't take the database down while you're doing it. So that has to be fast as well. So that's one of those moments where we have to like, okay, we're going to load a data breach. Let's scale up the database so we can actually import the data while data is being read from it as well. So it's as soon as you put a database in there that's like table storage is a very simple thing, but once you put the database in there, you have a lot more moving parts, which might actually impact one another. So yeah, that's sort of actually the starting point that we had. And then, of course, we ran into all sorts of issues. Like, I think it was, what was it, once where we actually accidentally put all the traffic onto the database. Was that at one point? They actually broke things pretty fast.
I remember when that happened, because it was like suddenly everything broke, and like I guess to be completely transparent about it, like we've broken numerous things during this process. Never like really major, but we've had times where databases haven't scaled, or we've dropped connections, or in your case, because we were sort of, as we were running table storage and SQL Server together, remember we were like, let's just send 5% of data, or 5% of requests to the SQL Server, and then accidentally that didn't work, and it was like 100% of requests. Oh, you got to talk about the parallelism as well. Like that was the thing that unexpectedly killed us early on.
Yeah. So if you're familiar with SQL Server, it has usually when you're working with a database like SQL Server, like more cores are better, and that's sort of that pretty much goes for any database. But the thing is, so SQL Server has these. I'll just call them quirks. It tends to be one of the problems. For example, in SQL Server, if you have, for example, a table constraint, like a unique constraint or something, that actually calls a function in the database, then SQL Server has a limitation that actually prevents pretty much any query that touches that table to go parallel, for example, because usually you want to be able to take advantage of like multiple cores. And if you're doing a big query, you want to be able to like read data from the table in parallel. But in SQL Server, if you have a check constraint somewhere on a column in a table, that table pretty much just forces SQL Server to put all the queries that touch the table, even if you're not touching the actual column that has the check constraint, even if you're not reading that, just the table is pretty much just locked to be serial only, and will only like allow one core to fetch from it at the same time. Which I would say like in 95% of cases you don't want that. You want SQL Server to be able to go parallel and fetch data as fast as it can from the table. So we had that on our backlog too. Okay, let's fix that constraint, because in that case, like we had a database function that validated the email addresses, but we'd already done that before we actually import them. So we thought, okay, we can just get rid of the constraint. And then we can like unlock a lot of performance in the database. So we did that, and basically like shit hit the fan, pretty much very quickly afterwards. And we started wondering like why is this happening? Because all the tests that we've been running, like all the queries were a lot faster when we actually removed that check constraint. But then when actual traffic started to hit the database, it just died. And that actually turned out to be because of the parallelism, because there is another limitation with Azure SQL, and especially the serverless ones. It's like we can say like we want this many cores, like we want a minimum amount of cores and a maximum amount of cores, and we have like a boatload of memory. But there's a limitation in there as well, which is called like a workers request limit. You can pretty much think of it like a rate limit on a web server, pretty much. Like it can only handle so many queries at the same time. And usually when you scale up, like that limit goes up as well. But then we actually ran into a problem where like even if we were just using like 20 or 30% of the CPU of the database, we actually managed to like exhaust all the workers, or like just blew the workers limit. And that was because like all of our enterprise customers and the people that were querying data caused a query to go parallel. So if we had like 20 cores running and you got 1,000 queries into the database at the same time, it would spread out to like 20,000 workers. And that just blew the worker limit, and SQL Server like got all pissed off about it and basically said no. Basically returned an error saying that we blew the limit. So it's one of those cases where you actually where you can actually see that like when you almost always want things to go parallel, it was pretty bad in this case. But then thankfully we found a way in SQL so that we can actually force queries to like say you're only allowed to use like this many amount of cores. And the other interesting thing there is like Microsoft had actually like sort of anticipated this, and they have a default limit for the amount of cores that a query can take in Azure SQL. But they only changed that, I think, in, what was it, 2018 or 2019. And because you created the database, like how many years ago? 10 years ago?
11.
Yeah, almost 11 years ago, then that setting was actually not grandfathered to any databases that were created before 2018. So our database pretty much just had the setting saying that like, yeah, queries can use any amount of CPUs or workers that they want, and that pretty much just like blew everything to bits. So that was one of the things that we actually had to figure out, because it was a tricky thing to find out as well, because like instinctively, like we started looking at like once the database goes down, we start looking at metrics and we're saying like, hey, it's sitting there at 20% CPUs, like why is it dying? And like we weren't blowing the like data limits or IO limits or anything either. But then we actually started looking at the workers. We saw that the worker limits were just spiking to 100%. So that was one of those interesting things to find out, which we actually couldn't, or was pretty much hard to find out except at scale. So it's not a typical thing that you can actually find out locally. I don't think I could even blow that many cores on my machine, like without having like a cluster or something to work with.
I think the sort of like the observation here is that we moved to SQL Server for lots of really, really good reasons, and I don't regret doing that as the like the primary source or the master copy of the data. But now we have to deal with SQL Server, and it's a combination of that parallelism, you know what I mean, and even things like not using the correct index. So we literally had to explicitly specify the right index to query when we're searching for an email address or a hash prefix, and that just wasn't in there, and it ran terribly. And then it's like, okay, one tiny little adjustment to the TSQL and we're good. I think that the thing that I'm lamenting at the moment is that I was just double checking the prices here. So we're running SQL Server, Hyperscale, serverless in Azure There's, I guess, a static cost for the data because the data itself is not changing size too much. Obviously, we're loading a lot more data, but there's so much in there already. It's as a percentage, it doesn't change much. The main thing is, and I'll express this in US dollars, is we're paying 41.6 cents per vCore per hour. And 41.6 cents doesn't sound too bad, except that's roughly 10 US dollars a day per core. The smallest that we can run is 2 cores, which is fine. And if we get our cache hit ratio high enough and enough load off the database, we can come all the way down to 2 cores, in which case it's $20 a day, which is good. The problem is, like, I'm just looking at our scaling history now, we're running on 20 cores at the moment, and we've been running on 20 cores for nearly a day, which means $200 for the day. That's 300 Australian dollars. That's a lot of Australian dollars. And maybe talk a little bit about how we're doing that scaling, because we're sort of playing this game of how do we make sure that we have enough resources to support the requests. And actually, I'll just tangentially, James made the comment here. He said, you can at least predict the traffic increase to scale it. This was obviously when we flush cache. And you're totally right, James, because we know that when we flush, we're going to get 100% of requests. We know roughly what our request rate is because we can look at, say, Cloudflare and see what's hitting there. So very often I've been going, okay, let's set it at 20 cores, and then we'll flush cache and we'll do everything we need to in terms of sending notifications, and then we'll flick it to auto scale, which definitely I'll explain in a moment. If we had unexpected traffic spikes, whilst we had a very low cache hit ratio, that would be harder. And then James also makes the point, maybe the cache flush could be timed when traffic is naturally slower, so traffic balanced out a bit too, which is also right. And I know that about this time of day now, so we're 6:30 in the morning in Australia, is like peak usage time. So if I was to load a data breach now and flush the cache, that's going to be harder to deal with than if I wait until about 10 hours from now and it's the lowest time, then that's going to put the least demand on. But because it takes quite a while for the cache to repopulate, we're then going to go into the busiest period tomorrow, and I'm going to have the same problem to deal with. So anyway, why don't you talk about, Stefan, how we're scaling that SQL Server up and down in terms of number of cores?
Yeah. So, like, because like I said, this had to be like we were playing this game, like you said, like scaling up before you load a data breach, and then like even if you would be doing things either like evening my time or evening your time, it would be like, okay, can you like scale it down like in about 3 hours once like traffic or something starts to go down, or we just constantly have to monitor the thing to look at the traffic. But then when we started looking at it, we actually saw that like you can actually scale the database by executing a SQL command, which was pretty interesting. And then we actually started looking, okay, then we can just like run SQL queries or like execute a piece of SQL to either like scale up or down, which is pretty handy. And then we actually started looking at, but what if we just have like a regular like SQL job running that looks at the performance stats of the database, and then we just execute like the scaling commands like automatically, like depending on what the performance metrics from the database is. And that's actually one of the neat things with SQL Server, like, and it's one of those things that's like very, in my opinion, like underutilized in SQL Server in general, because SQL Server has a boatload of metrics and statistics and everything else that you can query straight from the database. You don't have to be running a special monitoring software or anything. It's just like there's just different tables in it that you can query to see the amount of CPU that's being used, how much data or IO is being used, and everything else. So we wrote a few queries that basically gets executed every minute, and it looks at like the last 5 minutes of traffic on the SQL Server, and based on the data that we get back from that, then we either decide to like, okay, let's scale up to the next core limit or down again. So if the database is sitting there at like 20% not doing anything and has been doing that for a few minutes, then okay, we'll scale it down a bit again. Then we see like the CPU spiking up. And then as traffic increases, like once the CPU exceeds a certain threshold, then okay, let's scale up again. And then we actually have something that we can run. Well, we don't actually have to like sit in front of our computers pressing F5 or run again every time. So that was actually a pretty neat thing, and it's one of those things that like it was surprising to find, because like I knew you could probably do this via some Azure APIs or something, but it was fun to see it just be a SQL statement that you can run to scale the database up and down. It made things a lot easier.
Where are you orchestrating that from, though? Is that from like a function?
No, we just basically created a stored procedure for this. So we can actually call the same stored procedure. Like if you want to scale it up manually, then you can do that via stored procedure, or you just run it with like a default parameters and then it goes to auto scale.
Yeah, but what's
Then
calling
we
the
actually
what's calling the stored procedure?
like in a normal SQL server, you would be able to just create like a SQL job that's
Yeah.
like run every minute, but they don't have that in Azure SQL. But they have something called, I think it's called like Elastic SQL jobs or something. So we basically just like I don't know what they like run what they actually use to run behind it, but it's basically it's very similar to like a triggered Azure function, but you're basically saying like to like just execute this piece of SQL like every minute or every 5 minutes or something. It's I think people are mostly using it for either like data warehouse things where they want to like kick off jobs. We're actually just using it to like execute this one procedure again and again.
Yep, right. So it's the Elastic SQL job. I'm just having a look at the results here. So what we've now been playing with is, and even when I begin to explain this, I think what pains me a little bit is, remember in the beginning with cloud, where it's like, don't ship your VMs up to the cloud, just take what's on-prem and put it in the cloud, like, design for cloud native services and so on. So, we'd use things like the Azure App Service, and then the app service was still a logical container. It was still a box of a certain size. And then you could scale that box out based on utilization of CPU or memory or other metrics like that. And we had auto scale. And it was like, oh, well, this is really, really cool, because now you no longer have just this one logical machine. You can have more of them. But then every block of auto scale, you've either got too much or too little. It's never just right, because the traffic is never constant the whole way through. And then when that scale happened, you'd potentially lose some requests. And I feel like in a way, all we've done is we've rebuilt like the Azure App Service auto scale for SQL Server, which is meant to be serverless, but it's not, because we moved away from the app service model into functions, because functions really were just pay per execution and memory used throughout the execution period. And I guess in a way, we had that with table storage, and now we don't. And the thing I lament is we get all of this other cool SQL Server stuff like backups, really advanced stuff like that, and point in time restore and ad hoc queryability, etc. But now we have like a poor man's auto scale. I don't know. Is that a fair comment?
Yeah, I mean it's a pretty fair comment. Like when we're running, for example, like Azure SQL, like with hyperscale, like I said, you can set up like a maximum and a minimum amount of cores. But then that was one of the things that was like pretty frustrating to find out, that like the pricing is a bit, I would say, it's like it's not really transparent how it works. Like because you pick the max amount of cores and minimum amount of cores. Um, but you can't really like you can't say maximum 40 and minimum 2. Like if you go up to maximum 40, it's going to say okay, then the minimum is 16. Then like the minimum goes up with the maximum. Not and that's like many times maybe that would be okay, but like our like usage pattern is like rather doing we're doing like a lot amount of work, and then after as time goes on, we start doing like almost no amount of work. So it's like we don't really fit into that like minimum and maximum uh, like ranges that they have. And then one of the other things that we actually found out as well is Like even if the like when you're looking at the pricing, it always says like, yeah, you pay per amount of core that you have. But like if we could set it to like maximum 20 and minimum 2, and it would just scale between that, with the way that their pricing is set up today, we would always be paying for 20, even if we were just using 10% of the CPU, because one of the sort of like non-obvious things in their pricing model is that like they pretty much take like if you're using no memory, like pretty much no memory at all, they bill you for the cores. But as soon as you like exceed a certain threshold of memory used, they say like the cores don't matter. We're gonna bill you for like the full cores because you're using all the memory on the machines. Like you're using memory for 20 cores, even if you're just using like 5 of them on a CPU level. So that's why we started to think that then okay, then we just need to be able to scale this like manually or like with the poor man's auto scale that we're doing today. So it was I was thinking like just as you said it, like if they would just have put like a proper backup mechanism in like Azure Tables, we wouldn't even be having this discussion. Like,
Well, yes and no. And I am thinking about ideas around this now, but um, we we still didn't have the queryability, so we didn't have. I'll give you a good example. There's just some ad hoc stuff I need to run at the moment. I need to figure out like a count per domain for one particular recent breach, and we just couldn't do that before. Like we couldn't. Well, what we could have done is we could have pulled the petition that had the entire domain in it and then counted from there. But what if we need, for example, a count per breach? Sorry, a count per domain for a particular breach. Like that ad hoc queryability didn't exist. Or even when there was that, remember that Moi AI one, the AI girlfriend one that then had all of this like CSAM related content in it. And I wanted to figure out, are there people in here who also have linked, who are in the LinkedIn data breach? Like that's a 2 minute query to write, but we just couldn't have done it before. I think
yeah,
something you said there, which I still feel is just nowhere near clear enough in the Microsoft Docs, is that if you have, let's say at the moment we're running at max of 24 cores, sorry, 20 cores. So we've been running 20 cores for the last 16 hours and 21 minutes. Now, the scale is actually something like 4 to 20. But I'm looking at our graphs here, and our percentage is like the high 20% of CPU utilization. So you'd kind of go, okay, well, let's say it was 25% of 20 cores. So are we only paying for 5 cores? It's like, no, we're not, because we're using 85% memory. And I just found that that was really, really unclear. Like I'm on the hyperscale page at the moment, pricing page, and if I search for memory, there's 13 references to memory, but it's all about memory allocation. It's really, really unclear to me that that's a factor of price as well, as opposed to just this is how much you've got when you're paying for this many cores. Yeah,
yep,
that's kind of messy. So where we're at the moment, we've got this elastic job triggered stored procedure to go through, look at the utilization of CPU and worker. I think we're just about to drop down, hopefully just about to drop down a scale as well, because we're constantly then tweaking at what point do we scale down, at what point do we scale up. And if we scale down too early, we risk having performance problems. But the longer we take to scale down, we pay more money. So what's the next one down from 20? Is it like 14 or something like that?
I think it's 18 or 16.
So 18. Well,
Not sure.
let's say for the sake of simplicity, it's 18. So as soon as we can scale down, we reduce our cost by 10% because we're going to go from 20 to 18. And
Yeah,
before I loaded that breach yesterday, I mean, we got all the way down to 2 cores. So we can actually reduce our cost by 90% as soon as we can get down to 2 cores. So we want to try and get down there as fast as possible. But, we had issues like I got up yesterday morning and so, wow, that's that's a lot of errors that we had somewhere in the middle of the night because it just didn't scale properly. And the problem that we're often having, the exceptions that we're having on the app tier are not timeouts, it's connection limits. Because you get X number, I don't know how many connections we get, but it's like X number of connections per core. And if we exhaust the connection limit, even if the CPU utilization is low, then we drop requests, and then the app has to retry. And then suddenly you get all of these threads retrying together and you just get smashed with requests.
Yeah, it's an interesting like scenario to deal with, and that's one of the things that we actually started to look into as well with the database. Is what happens when you scale down, because scaling up is usually not a problem because behind the scenes it's just more machines being added into like a cluster or whatever they have behind the hyperscale thing. But once we're scaling down, we're actually severing connections. And then we have to be able to handle that in our app code. So that was actually another change that we had to make to make the SQL like statements resilient. And thankfully, like Microsoft has actually added like a built-in mechanism to that into their like SQL Server libraries to be able to like retry queries when they fail under, and you can actually specify like if you get this in this error code, then you're supposed to try again, otherwise just like do a hard fail. So that was one of the things that we had to look into as well.
I'm just looking at underlying function execution, so looking at App Insights. And if I look at the last 12 hours we've got a function called data source range. So when anyone does a search, whether it's a k-anonymity search or an email address search, it gets translated into k-anonymity. If it's not there in cache on Cloudflare, it hits this data source range function. And over the last 12 hours, that's been hit 4 million times. The duration is 90.5 milliseconds. The 95th percentile is 190 milliseconds, which isn't too bad. 50th percentile actually is 71 milliseconds. That's pretty good. And the line of duration is really, really constant, just under that 100 millisecond mark, which is great. So we've seen scale. Actually, we haven't seen scale operations in that time because the last scale operation was 16 hours ago. But if I extend this graph to like 24 hours, that's when we actually had some serious problems. And we've got some spikes there where our average execution time went from like 90 milliseconds to over a second because we just didn't scale. We didn't scale fast enough. And then we had all these drop connections and they all retried. So we keep tweaking that to try and get it right. But the elephant in the room, and I did put this in the blog post as well, is that a significant portion of that traffic, I think about more than 90%, is from one subscriber. and it's not that they're so much bigger than everyone else, it's that everyone else is using, we've got a webhook model, so that if we load a data breach, we can have a subscriber, let's say it's 1Password, for example. 1Password can say, look, these are for example, the 1 million hash prefixes we want to monitor. And what we can do then is say, okay, well, for any of those 1 million hash prefixes that are in this new data breach, we will queue a callback to send to you, and that gets dropped into a storage queue on breach load. We then have a function that picks up that storage queue. It's triggered by queue insertion, and it sends a callback directly to the subscriber. So they get told like pretty much instantaneously, or very, very quickly, certainly within like an hour, even for a very large breach, that, hey, there's a new record in that breach. And for this hash prefix, here are all the suffixes that were in there. And that's super, super efficient because none of that really hits the database because it's just done at load time. It's like, well, we've already got this in a transitional table anyway. Let's just grab it, drop into storage queues. It pushes the data out to the subscriber. They hear about it very quickly. And then unfortunately, we've got this one subscriber that's like, no, let's just keep polling over and over and over again. And that's what's kind of killing us at the moment. And that's why when you look at the blog post and you look at the graphs, it's a really, really consistent daily pattern. So I think philosophically, I like us having to make decisions under pressure, because I think we come out with the best solutions when we're pressured to do so. But and I am chatting to this subscriber, if we can get them to do what all the other ones are doing, this problem like goes away. But then how long, like at the moment, it's taking 20 hours to get to like a 50% cache hit ratio. If we take that subscriber out and we put them in the same pattern as the other ones, how long does it take then to get to that cache hit ratio?
Yeah.
Way, way, way
I mean,
longer.
yeah. 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 I mean, like, it's, these problems are like, they're sort of, you pretty much like call them, they're pretty much like a success problem. Like we're dealing with the problem because we're getting like a boatload of traffic into the service. But then, like you said, like we have better options that would be better for the subscriber to use. But then, like you can also like look at like we no idea like what their infrastructure is like. It might be maybe it's a big deal for them to change it, and maybe it isn't. I don't know. Kind of different depending on like organizations as well.
I mean, it's obviously not naming them just for privacy reasons. 1Password and Mozilla willingly talk about this publicly, but everyone else, deserves the privacy of being one of our customers. But you know who they are, and I think that they're actually very technically adept. I don't question their technical ability, but I just feel like they haven't really thought through the most efficient way to handle this. And I think we're just going to get to the point with them where it's like, look, this is actually really burdensome, this pattern. I need to check the terms of the agreement, but it might be like, look, you can change it to do what everyone else is doing, or you can pay for the usage, because it's kind of, I guess a lot of things end up with this Pareto's law kind of thing, where it's like 20% of people using 80% of resources, except this is like, a single digit percentage using almost 100% of the resources, which just doesn't seem very fair.
No, yeah, no, I agree there. It's just like just a matter of like getting the correct incentive for them to use, like to get them to move over to something else.
Someone, I actually saw a couple of comments. So there's a comment on the blog post about warming the cache, and I saw one or two comments on social about warming the cache, where their position was, well, what if you just load the data breach and then just populate the Cloudflare cache straight away? And the problem with that is that at the moment, let's say for the sake of argument, it takes 24 hours to populate the cache 50%. And then we load a data breach every 24 hours. Effectively, then, each time we load the data breach, we flush the cache. We've had to pay to cache 50% of the database. Now, if we were to just flush the cache entirely and then warm the cache by effectively, we would probably have to go through and just literally make 16.1 million requests in order to load all that data back up to Cloudflare cache. We're going to pay for 100% instead of 50%. And that's sort of the problem we have, where warming the cache is not going to make a fundamental difference to the end users, assuming our database is scaling properly and not dropping requests or anything. But it's going to guarantee that we pay the maximum amount possible in order to process all of those requests and get the data in there. It would give us more predictability around ongoing requests, but, again, sort of at what costs? And something we didn't touch on as well, but it feels like it's a shame to have like 16.1, let's say we get to 100% cache hit ratio, got 16.1 million cache entries, and then we load a data breach, it's got 100,000 email addresses in it, and then we flush out all of the 16.1 million entries in order to load 100,000 new email addresses. We can't selectively flush out 100,000 records by cache key, because I think we're limited to about 300 on enterprise. Was it 300? I wrote it in here somewhere. On Cloudflare's enterprise. Um,
Yeah, or I think it was like 30,000 per hour or something we can do.
it
Like,
yeah, it's and I mean 100,000 is almost a trivial example. Let's say it was yesterday's 900,000. We don't want to be sitting there making either 900,000 or if we can do 300 in a batch or something, what's that? That's still going to be like 3,000 requests or something out to Cloudflare's Edge node in order to flush that cache. I was thinking we could almost kind of do it the other way, where we could always set the worker such as if we pass some sort of parameter, it always goes to source. And then we could make 300, let's say it's 100,000 record breach. We can make 100,000 requests to our API, and then they all go back through to the source and we just repopulate those ones. But that's messy. And what about when it's 1 million or 5 million? Like it's just messy, messy, messy. But the only thing that I was just starting to toy with in my mind as we've been talking about this today is like table storage was pretty good. I wonder if we were still parallel loading into SQL Server and table storage. Yeah, like all of this problem kind of goes away. But I just and if we were backed by SQL Server, so we always had that as like our master copy. But yeah, it just feels messy, doesn't it?
yeah. I mean, there are the ways that we have had some ideas from, for example, people at Cloudflare that say like we do have cache tags. We can put tags on the, for example, we could tag by prefix, or we're pretty much doing that already, but that's still like 16 million tags that we have in there. But then there's an idea of if you could, for example, tag them based on just the first three characters, like how big would the data breach have to be to fill all three characters of the hash prefix? Or could we then be in a position where we could say that like we only have to purge like 20% of the cache instead of everything?
I was just
So there are,
thinking,
there are some ideas that we can actually look into there, but that's something that we've just pretty much just finished this. So we have a drawing board that we can actually go to and start looking at things so we can do this more efficiently, because I'm certain there are ways that we can actually do that.
I was just thinking about that tag option and like a 3 character hash prefix. So then we've got 16 to the power of 3 different possibilities, which off the top of my head is going to be like probably 3,000 something different possible tags. Um, yeah, yeah, it could get us part way there. The other thing, and I feel like we're sort of starting to exhaust our options here, but if that underlying stored procedure was more efficient, like let's say it used half the resources, that would give us a much bigger runway. But I just don't know that we can optimize either that procedure or the underlying indexes anymore. The only other thing we could possibly do is like denormalize the data a little bit to save the joins.
Maybe might be an option, but then we're like, I think we pretty quickly start running into then like um as soon as we start, for example, denormalizing data, it's also gonna take longer to insert the data because you're
Yep.
inserting more data into every row. So like we just recently, for example, like got our like breach load times down like quite a lot. But I wonder like if we would either like add an index or denormalize things, like how much would we be pushing that data load time up again?
Yeah,
Because we don't want to be in a position, for example, if you're loading a data breach with like 100 million records, it's going to take like 48 hours to upload them.
because that's where we've just come from, right? Like we just literally
Yeah.
came from we managed to over the course of like a decade get table storage loads really fast, but the SQL Server load was actually going really slow. And now we're actually pretty efficient. Really only as of about the last 2 weeks, isn't it? In fact, if I do let's run a little report on this because we've got a little store procedure on this report breach load statistics. And if we look at, say, demand science, that was what, 122 million?
Mhm.
I've got to spell demand science right. So we've got sort of, I guess, 6 procedures that are, well, really 5 procedures that are running here. So we've got to extract all the unique domains out of there. So we had 100 let's call it 122 million records. I think Demand Science was a little bit of a unique kind of data breach in that it was scraped public company data, so it was very, very corporate heavy. But anyway, there are 3.5 million domains in there. It took 41 minutes, 42 minutes really, to extract all those domains out. Okay, that's a little while. It then took, we then set the domain IDs because we've already got a table of domains. So we've effectively got an ID foreign key on our imported data. That took another hour 14. It then took another hour and 22 minutes to insert new email addresses that we didn't have already. There were 64 million of those. And then it took another 3 hours and 50 minutes to set all the IDs of every email address we have on our import table, because we've got sort of a staging table. So really, when you look at it, what's that, 5 hours, 6 hours, 7, probably took about 7 or 8 hours to process that. And that's only 122 million records. Like, what are we doing? There's a 500 million. And that was also scaling the database up to the max cores. So keeping in mind, it's like $10 per day per core US. And then we can scale up to 80 cores. Now we're $800 US a day. And the thing potentially has to run for multiple days. That starts the thing. Yeah. All right. Let's just agree that stings. I don't have a better answer at the moment. And we can't even blame that one large subscriber for that, because that's literally just us inserting data into existing tables.
Yeah. I mean, they're like our first sort of instinct was to like go with SQL Server as well, but mostly like you mentioned before, like because of like we have proper backups there, and like you actually tested, like we were able to restore like a full backup in like what was it, 1.5 hours, something.
Yeah. Yeah, that's
So we,
good job doing the glass half full thing. It is really good to be able to restore so quickly.
yeah, but then like we also didn't look at like there are only two of us really, and we actually were in a position that we actually needed to move this data over at some point as well. Because it was not just backups, there was also like what was it? Microsoft was it like obsoleted like one of their storage. What was it? Version one of the storage accounts.
Yeah, and we
So
were
it was
worried the upgrade might actually kill stuff, and it actually turned out the upgrade was a no-brainer, wasn't it? It was very seamless.
yeah. Yeah, but we were like that's sort of trying to get at, because we were pretty much under a time constraint there when we were taking something to migrate over to. But then like we didn't really take a full look at all the options that we had. But like but then again, like once you start looking at data, there like I'm not sure that there really are many options that we can look at, but maybe there is something in there, or some version of either SQL Server or another database that they have like that would be a better fit for it. But that would be something that would just require a ton of research to look into as well.
Yeah, and I think this is what some people miss, where there's always someone who's like, "Hey, why don't you use blah 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 newfangled other thing that we have never heard of before?" And you're like, "Well, yeah, part of the problem is familiarity. Like we understand to varying degrees what we're doing in the SQL Server environment. If you have to go to something completely new and then go through that learning process when we're already like overwhelmed and just trying to keep on top of things, that's then a hard ask. So I feel like there's probably still places where we can make gains here. Not least of which, of course, is just taking off a bunch of the traffic load, which would really, really help. But yeah, we'll just see. I still think some of those larger breaches are going to hurt a little bit to get loaded. But mind you, they did before too. I'm quite sure that some of those really, really large ones were still taking more than a day to get into table storage, when we get to many hundreds of millions of records. So if we took 7 hours roughly for 122 million records and at pro ratas, then, 500 million is going to be about a day. And we just have to pay the $800 in order to get it loaded, and that's just what it costs. So that, yeah, at least there's a revenue stream to pay for it now, which there wasn't before. So that allows us to do stuff like this, really, doesn't it?
Yeah, I mean, but then like also like we've seen like Microsoft tends to like every few years they actually like either like put up a new version of SQL Server into Azure or something, or actually they upgrade the what they call it. They call it like service tiers, like premium tiers or
Mm.
whatever. They tend to update like the VMs between those as well. So like I'd be expecting us to be able to like upgrade in some way for actually make things faster. Either like by like having a disk upgrade, which will actually help us a lot, especially during data loads, for example.
Yeah, yeah. Well, I think just the fact that we'd done so much mucking around with it, scaling up, scaling down, figuring out where the right, load points are and everything, that's kind of cost us. So as I start to look at our costs now, in fact, one of the things we've got to do is do some good dashboards. I'm drafting you an email about stuff I think we should do next. But when I look at our database costs now, at least we're sort of, yeah, much lower than what it was before, because that's the thing that can suddenly come out and really, really sting you. And if we can get it down to, let's say it's even like 8 cores on average per day over the course of different breach loads and so on, then that's $80 a day, and that's not too bad. I think that's probably going to be more feasible. I could
Yeah,
also try and I think that part of what I lament is I don't want to get to the point where uh, cost is starting to drive things like breach load. And even as it is, like loading a breach in the afternoon as opposed to loading one in the morning, it kind of doesn't make a lot of difference if it's not some time critical thing. But I just kind of don't feel 100% comfortable with price driving that. And what I was going to say is it'd be much more efficient if I've got 5 breaches to load in a week, if I did them all at once, and then just flush the cache. But again, that means delaying a bunch of stuff days, and I just don't feel good about that, because a lot of the value proposition is letting people know as soon as possible when they're in a breach, and I yeah, I just don't like that. But we'll see. Okay, well, look, I think we're
yep,
sort of exhausting this. I'm going to see you in person in a few weeks in Oslo, so that will be good. We
yeah.
can. I've got some good ideas about stuff we've got to work on then. And for everyone else listening to this, I hope you found it useful. I know a bunch of people stuck around while we're going through this. Stefan is going to get a blog post out at some point around all that SQL scaling stuff. And I find that very often when we write about stuff and you put it out there publicly, it helps us solidify our strategy in our brains. And you often get people then pop up and say, "Hey, have you thought about BAM?" So I think get on with that. James just made a comment. He said it'd be interesting if there was a way to manipulate the hash in a way that let you flush a smaller amount of the cache when a new breach was loaded, kind of like tagging them with an epoch. Yeah, which is kind of what Stefan was saying about having cache tags that we could, rather than flush 100% of things, we could flush, like 1%. Or but again, that's just difficult to do when you've got 16 million possible things to flush.
Yeah, it's one of those. God, 10 minutes. Like it's one of those things which actually like because this pretty much all stems from like the k-anonymity model that they have, and that's the awesome thing about it, that we can then have like a finite amount of like requests that would actually like encompass all the data sources. But that also means that like we don't really have to get a pretty very big data breach to actually exhaust all those ranges as well. Like that's
Yeah.
one of the like it's one of the cons of having like a finite list of URLs, is that like you're going to run out of them as soon as you have like X many items to put in there.
All right. So yeah, James enjoyed that. Thanks very much, James. Thanks for joining. If anyone listens to this later on and you have great ideas about how to make this better, please let us know. Drop it in the comments or get in touch with us on the various things. Let's wrap it up then. I'm going to go start my day. You're at the end of yours. You're going to try not to get swallowed by the volcano today because we have work to do. It's Iceland, so there's another volcano. But yeah, cheers, mate. Thanks for joining.
Thank
See you,
you.
everyone.
See you later.